Welcome to True Projects. In this video, we are going to explain about the project that is CloudProphet, a machine learning based performance prediction for public clouds. Before getting into the execution, first let us understand what is the project about. So think of a laptop that multiple people they use at the same time, and each person they have their own accounts and they run different programs. Maybe some of them watching videos, others are editing documents, and few of them are playing the games. And even though each user has separate account, they all share the same processor, memory, and also storage. When too many people use it heavily at once, the system slows down. So this is similar to how cloud computing works. Companies like Amazon, Microsoft, and Google they run massive data centers where they create virtual machines. So they are called as virtual machines. They are software based computers that share the same physical hardware. And virtualization, this helps to divide these resources efficiently. But it doesn't guarantee that each virtual machine get consistent performance. It doesn't guarantee that each virtual machine gets consistent performance. So they still compete for shared resources like memory, bandwidth, cache, which act as computers' short term memory. It is if one VM uses too much, other might slow down. And on top of that, the cloud providers can't directly monitor what is running inside these virtual machines due to privacy policies. It is like renting a storage locker, and the provider owns the facility but can't open individual lockers. This makes it difficult to predict and manage performance issues, leading to unexpected slowdowns. That's why accurately assessing and predicting this virtual machine performance is a key challenge in cloud computing. And think about how food delivery app work. When you are ordering something, the app assigns a delivery person based on location, availability, and traffic conditions. So if the system makes a bad prediction like assigning someone stuck in heavy traffic, you will end up waiting longer than expected. So that is what happening with the cloud computing when the performance prediction are off. So cloud computing, cloud providers use different techniques like heuristics, which are basically rule based shortcuts to manage how virtual machines share the resources. The problem, these methods assume ideal conditions which doesn't exist in the real world public cloud environments. So these VMs act like locked boxes. Cloud providers don't know exactly what is running inside, making it harder to predict performance accurately. And because of this, the current models they don't handle unpredictable workloads well. They don't consider how multiple VMs competing for resources, and they can slow things down, leading to bad predictions. If cloud providers can't predict performance properly, they can't distribute resources efficiently. That means some applications struggle while others get more than they need, wasting server power. So to fix this, a machine learning based system is needed. One on that can learn from real time usage patterns, understand workload variations, and make better predictions. With smarter performance forecasting, and cloud providers can balance resource efficiently, effectively, prevent slowdowns, and improve overall efficiency. So, when managing cloud environments, it is important to allocate resources efficiently so that applications they run smoothly without performance issues. Traditional scheduling methods they try to improve this by following set of rules, but these rules don't always hold up in dynamic cloud environment. Since workload can change unpredictably, a more adaptive approach is needed. And this system uses machine learning to make accurate performance predictions. So it works with three steps. So the first step is application type identification. That means the first step is figuring out what kind of application is running inside the virtual machine, that is VM. This is important because different applications need different amount of CPU, memory, and also the other uses. To do this, we are using dynamic text wrapping. So here we are using DTW, that is dynamic time wrapping, to improve any time mismatches in the data. After that, Euclidean distance is compared. Euclidean distance is calculated to compare the test data with a reference data set. So this helps in identifying the closest matching application, ensuring that virtual machine is assigned resources that suits its needs. Then comes high correlated metric selection. So here in this step, not all the performance metrics have the same level of importance. Some are more relevant than others when it comes to predicting VM performance. To identify the most useful metrics, the system applies Pearson correlation. So here, Pearson correlation has been used. So this Pearson correlation, this is a mathematical approach that finds relationship between different performance factors such as CPU usage and memory consumption. By selecting only the most relevant metrics, the system improves the accuracy of its predictions and avoids unnecessary calculation. Then comes machine learning prediction. So here we are using neural network model. Once the important metrics are selected, they are fed into the neural network that predicts the workload of virtual machine. If the workload is predicted to go over 100%, it means that virtual machine it will struggle to handle the demand and additional resources are needed to prevent the performance degradation. If the workload is below 100, that is below 100%, the virtual machine is operating efficiently and this ensures that resources are allocated optimally, preventing slowdowns and improving overall cloud performance. So this is the proposed system of the project. Now, to further improve the performance, here in this project, as an extension, GRU, that is gated recurrent unit, has been incorporated. It is used as an alternative method. So here this GRU offers better accuracy while reducing computational overhead. Additionally, instead of just predicting whether the performance is optimal or degraded, GRU also classifies the application type running on VM, making resource allocation more precise. So here we will be predicting whether the virtual machine's performance is best or degraded, and also we will be predicting the application type. And here, to make the system more accessible, a Flask based web interface is integrated. This interface provides secure authentication, that is, ensuring only authorized users can access the system. It allows users to input feature values, processing them through the train model, and visualize virtual machines' performance predictions in an interactive way. So now moving on to the implementation. To implement this project, we have followed the steps mentioned in the flow of work. So first, we have loaded necessary Python libraries like NumPy, Pandas, Scikit-learn, TensorFlow, Flask for data processing, model training, and deployment. Then comes data collection part. So here we load the resource dataset.csv file. So this contains system resource usage data such as CPU memory, disk, IO, and the network activity. Then comes data pre-processing. So here we remove unnecessary columns to reduce noise. And then we use Pearson correlation to select the most relevant features. And we normalize the data set using min-max scaler to ensure uniform scaling. And then we split the data into two sets. One is training set and the other one is testing set. Training set is used to train the model and testing set is used to evaluate the model. And then we define the structure of the neural network for the performance predictions. Then comes model training without DTW. So here we train the model on the selected features without applying dynamic time wrapping. So here DTW, I mean, we will be training models without applying the DTW for baseline performance comparison. Then comes DTW based feature selection. So here we apply DTW to handle time dependent mismatches and improve the feature selection, that is feature alignment, for better predictions. Then comes the model training part with the DTW. So here we retrain the model using features refined through the DTW, improving accuracy and everything. Then we evaluate all the models which are trained using evaluation metrics, and we have developed the front end using Flask framework with the registration and login functionalities which is supported by SQLite 3. And in the front end users, they will be able to provide the input feature values, and that will be pre-processed at the backend. It will be fed to the train model. Finally, outcome will be displayed through the front end, predicting the application type and also the performance type. And here, these are the algorithms which are used in this project. So this is the existing model, this is the proposed model, and this is the extension model. And to implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And now coming to software requirements, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let's execute. So open the code folder which contains source code files. Let's open the code folder. These are the source code files of the project. So let's understand each of them. How will they be used in this project? Here in the dataset folder, we have the dataset that is used in this project. Let's open it. So this is the main dataset that is used to train the models for predicting the application type. So this is the dataset. Now close this. And in this file, we have the test data that we will be using in the front end for predicting the performance. And here in this model folder, we have the algorithm information that is stored in the .h5 files, numpy files, and pickle files. that will be loaded into the project code during runtime of the application. And here we have static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the notebook file, that is the Jupyter notebook file, which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the main.py file. This is the .py file contains the information related to front-end logic. This is python.py file. And it includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the Windows BAT file. So instead of executing this project through command line interface, we have created this Windows BAT file. And now we are supposed to double click on this Windows BAT file to execute the project. So here you can observe, right, that Python main.py file has been compiled. So the Flask framework will host the application locally at the default address, which is the local host, and the port unless configured differently. So now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link at the end, type index.html and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So now get logged as user, click on user login and give your username and the password. So that is admin's username and the password. Now click on login. We have logged in successfully and redirected to prediction page. So here we can see predict cloud performance link, right? We're supposed to click on that. And here we can see a choose file button. We need to click on that for uploading the test data file. So click on that. Let's upload this one. Click on open and now submit. Before submitting, let's see what do we have in the test data file. So open the data set, open the test data. So this is the data. I mean, these are the different test cases that we will be uploading now. So here we have attributes as timestamp, CPU usage list. It is memory usage percent. Like that, we have multiple attributes. Now close this. Get back to the application. Click on submit. So this given information, it will be pre-processed at the backend. It will be fed to the train model. Then train model will be giving us the prediction. So just wait for a while. File is being pre-processed at the backend. So here we got the prediction for all the cases that we have given. So these are all the test cases. This column contains the test cases and this column contains the predicted performance and this column contains the application type that VM belongs to. So this for the first case, here we got the prediction that VM has been detected as best performance detected. I mean, best performance has been detected for that VM. And it is identified as that is of application type 0. And for the next case, performance is the best and application type is 1. And for the next case, application type is 1 and it is best performance. And with this case, here we can observe, right, performance degradation has been detected. That means performance of that VM has been decreased and it is of application type 4. Accordingly, for all the cases that we have given, we have the performance detection and also the application detection. So now click on logout. In this way, just by giving the values, I mean attributes of virtual machine, the application will predict whether it is performing best or whether its performance is being degraded and it will also predict which type of application it is. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.